Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about the weather phenomena that is referred as La Nina and why the cooling effect of La Nina has not helped in reducing the temperature that we witnessed across the globe in the past or the last month of January. So let us try to understand in detail about how La Nina produces cooling effect, what is this entire phenomena, atmospheric phenomena is all about, and what is the overall other implications when such phenomena develop in the world. Now, to give you the context of this particular topic, in the last month of the January, the scientists have recorded it to be the hottest January with a global average surface temperature is 1.75 degrees Celsius above the pre-industrial level. When I talk about the pre-industrial level, the time duration to take into consideration is between 1850 to 1900 on the average. We know that after the industrial revolution, we have emitted such a huge amount of greenhouse gases such as carbon dioxide, methane and all, and these gases then trap the energy within the atmosphere of the earth, causing rise in temperature. So that is why it is good idea to measure and compare the temperature between pre-industrial and post-industrial level to have understanding about the impact of industrialization and the global warming. So obviously if you compare with this particular pre-industrial level temperature, the temperature of January month was 1.75 degrees Celsius above it. And this is something that is a cause of concern, because if you remember, in the Paris Climate Agreement, many countries across the world have agreed that we should try very hard to ensure that the global temperature rise does not go beyond 1.5 degrees Celsius as compared to pre-industrial level by the end of the century, that is 2100. Now, the temperature reached record-breaking levels despite the development of La Nina condition. Why despite development of La Nina condition, we are going to discuss in detail. But first we have to understand that in the tropical Pacific Ocean, every 3 to 5 years, at the interval of 3 to 5 years, we have development of La Nina condition, and this produces a temporary cooling effect on the global temperature. So this is something that the scientists were expecting, but this did not happen as expected. And also if we talk about the La Nina has emerged late this year. Generally it is believed that La Nina it was expected that La Nina would emerge in September, but now it has emerged in December 2024, and it would have brought relief from the heat, but that has not happened. This is the data that we have received from the Copernicus Climate Change System, a system that has been developed by the European Union countries. Now, if you look at the La Nina, before understanding it, we need to have understanding about the Walker circulation. So, what is the Walker circulation? In simple term, we can explain the Walker circulation, as we can see from this particular diagram, is the east to west circulation of the wind between the tropical part of the Pacific, eastern part of the Pacific, and the western part of the Pacific. So the longitudinal or east-west circulation across the equatorial Pacific is known as the Walker cell or Walker circulation. Now, obviously, the region behind this movement of wind is the temperature and pressure difference. We know that the wind moves from the area of high pressure to low pressure. And we also know that if in any region the temperature is high, that means air will become warmer. If air becomes warmer, it will move in the upward direction. So, along the zone of high temperature, you will see the upward movement of air. And along the zone of low temperature, air becomes cold, that means it becomes more dense, and then it sinks in the downward direction. Thus, in this area, you will have high pressure, and here you will have the low pressure. So, wind is moving from high pressure to low pressure. Other thing is that if the air mass and the warm air is moving in the upward direction, and if it is carrying a huge amount of water vapor along with itself, further in the upper part of atmosphere, this water vapor will undergo condensation that will result into cloud formation, and that will result into the rainfall. So what we can say that above the high temperature zone where you have the low pressure region, you will also witness heavy amount of rainfall, and this is exactly what happens in the equatorial Pacific region. So Walker cell is just driven by this temperature and pressure differences, and that is why areas of high pressure we have cooler region, and areas of low pressure we have the warmer region. So this is the Walker circulation, and in the normal years you see the low pressure area develop toward Australian coast, and the high pressure area develops toward the South American coast, more precisely along the coastline of Peru. Now, sometimes this circulation reverses. For example, in some years, what we see is that the high pressure area developing over Australian coast and the low pressure area developing over the South American coast near Peru. And when this kind of circulation starts in the atmosphere and at the surface of the ocean, we refer it as El Nino. Now, El Nino is responsible for warming of the Pacific Ocean, more precisely the Western Pacific Ocean, because as we can see, the wind that is flowing above the surface, near the surface, they carry the warm water toward the coastline of South America. Sometimes we have the upward movement of air from the central part of Pacific Ocean, and both along the coastline of Australia and South America, as we can see, we have the subsidence of air mass. When this situation emerges, we call this phenomena as El Nino Modoki. Now, sometimes there is a reversal of El Nino, but reversal, as we have discussed, is Walker circulation. However, many times the Walker circulation itself become much more stronger and intensified in nature. That means you have a very intense rise of warm air near Australian coast, and you have the subsidence of the cold air near the South American coast. And then the wind flows at very fast speed from the South America toward Australia near the Pacific Ocean surface. So when this situation emerges, we call this as a La Nina event. And La Nina event is responsible for cooling of the water near the South American coast. Similarly, if the air is rising near Australian coast as well as near the South American coast, and then the air is sinking near the central part of the Pacific Ocean, then this is what we refer as La Nina Modoki. So as we have discussed, Walker circulation can have three phases. One, the warming phase, which is referred as El Nino or El Nino Modoki. Second is the neutral phase, that is Walker circulation itself, as we have discussed. And third is the cooling phase or cold phase, where we have development of La Nina or La Nina Modoki. So now in this topic, we are concerned about the understanding of La Nina. Now suppose when the La Nina like situation develops, what we see is the development of what we can call as a high temperature area near the South American coast, and this region experiences very heavy amount of rainfall. Similarly, due to the Modoki or during normal La Nina, you'll have the subsidence of air masses near the Australian coast. You have the subsidence of air masses near the Australian coast. That means here you have the development of cold air, and then the wind that is moving from high pressure to low pressure brings the cool water from the eastern Pacific toward the western Pacific, and thus it causes warming along both North American and South American coast. So because of this kind of movement, what we observe is generally a cooling effect across the entire world due to the La Nina event. Now this we can link with the global warming as well, because whenever you have the La Nina like situation, as we have discussed, you have the development of cold sea surface. That means the temperature of the sea surface becomes colder, its temperature decreases. So if the sea surface is colder, that means we know that atmosphere and the ocean surface are continuously interacting with each other. So colder the sea surface, more heat it can absorb from the atmosphere, and more the heat is being absorbed from the atmosphere, lesser will be the atmospheric temperature. So it is through this simple mechanism we can understand the ocean surface is taking heat from the atmosphere, resulting in its cooling. Now the question comes that why did La Nina did not cool temperatures in January then, that is in this particular year. So several reasons are there. First of all, we know that the La Nina cycle is not always of same intensity every year. So in this particular year, the La Nina that we have witnessed is having a weak intensity. So as they are having different we can say intensity, there is large scale variation between one year and other year. So the variation in intensity, duration, and the specific regions impacted with La Nina also changes in different episodes. So this is something that is responsible for we can say no, we did not see the exact intensified impact of La Nina because of this region. Second is also the emergence of La Nina, as we have discussed in the beginning of video as well, has been delayed. For example, scientists were expecting it to occur in the September, but instead of September, it has occurred 3 months later in the December. So ENSO events peak in the northern hemisphere winter, and there is just not a lot of time for La Nina to strengthen because of its delayed emergence. And this is something that has been accepted by the US National Oceanic and Atmospheric Administration as well. So weak intensity, delayed emergence, these are two other factors. Now there are some factors that has affected atmosphere as well, which might have resulted in the reduced efficiency of La Nina to promote cooling. And one such factor can be the rise in the heat trapping atmospheric carbon in 2024. So in January 2025 also, if you measure the heat trapping atmospheric carbon that has remained above the already high levels of previous year. That means the GHG emission that all the countries together have contributed to the atmosphere has rose to we can say a maximum level or the highest level if you compare it from the past. So obviously higher the amount of heat trapping carbon, higher will be the temperature in the atmosphere, as most of the heat lost by the earth's surface will be trapped there. Second, the dip in concentration of aerosol also can be blamed, because aerosols have two major important role to play. First, aerosols scatter the solar radiation back into the space. So the amount of energy that should be incident on the earth's surface reduce it itself. And second impact, the aerosol has impact on the cloud formation. So it affects how much sunlight is absorbed or reflected. So now in the recent times, all the countries are trying to reduce the amount of suspended particles in the atmosphere, largely to promote what you can call as a clean breathable air. However, this has also negatively impacted the temperature, because lesser the amount of aerosol, lesser will be the scattering of the sunlight, and higher will be the atmospheric temperature. So four major reasons now we can understand, we can give behind the lack of cooling in the month of January. Again, to revise, first what do we have is the weak intensity of La Nina. Second, what do we have is the late emergence of La Nina. Third, we have the higher amount of carbon, heat trapping carbon in the atmosphere. And fourth, obviously, is the lower amount of aerosols in the atmosphere. So that is the four major reasons. Now, apart from promoting cooling, La Nina has several other impacts as well, including over the Indian subcontinent. For example, in those years where we witnessed La Nina in the Pacific Ocean, we generally see a trend of a strong and above average monsoon. That means the monsoon is surplus over the Indian landmass. Widespread drought, however, is observed in the United States and also along the Horn of Africa, because the rainfall is very less, temperature rises significantly, that can also sometimes trigger forest fires and all. And flooding in Australia, Indonesia and Pakistan, again due to surplus amount of rainfall. So these are some of the effects that we can associate it. Now, what we can say is something that World Meteorological Organization, a prestigious international organization, has talked about, is that a particularly warm January does not reflect or does not tell us about the long-term trajectory of weather patterns on the planet. That means we cannot say that just because this January month was the hottest on the record, this will keep going on, or trend will continue over the next 10, 20, 30 years. That is not true. Trend can reverse as well. However, what we understand that the ability of the natural cooling phases to temporarily bring down global temperature might be waning, that means might be reducing. For example, a decade back, the influence of La Nina on cooling the atmosphere, the extent to which it could have caused the cooling, today we will not see cooling to that extent. So that is one takeaway we can understand from this particular development. And even if we talk about, many experts argue that even if suppose La Nina cooling influence temporarily might have caused reduction in the global temperature, it will not halt or reverse the long-term warming trend, because you know the long-term warming trend is largely driven by the anthropogenic factor, that is the emission of greenhouse gases due to continuous urbanization and industrialization. So unless and until we participate in a massive shift from the non renewable we can say from non renewable to renewable energy sources, from the fossil fuel driven vehicles to the clean energy driven vehicles such as electric vehicles and all that, will not see any significant changes in the warming trend, and we might be very well overshoot the target that we have given to ourselves under the Paris Climate Agreement. And that seems more likely given that under the Trump 2.0 administration, US has decided to withdraw from the Paris Agreement. And why it is significant? Because today US is the largest emitter of greenhouse gases in the atmosphere. And unfortunately, the Trump administration anyway has termed global warming and climate change as nothing but a hoax. So we have to wait and watch and see that how we are going to tackle the problems and the issues and concerns related to global warming. So that is all about this particular video. I hope you got the idea about what is La Nina, what is El Nino, and how these affect the global atmospheric temperature. That is all for this particular video. Thank you very much.